Hello everyone, good evening. Welcome. Today we will talk about how to design schema. Rather than saying how to design schema, when to design schema. Like before data arrives into your tables, is it better first create the schema of your table and then bring data into the table? Or first store your data and according to your data, then you can plan the schema. You can define the tables by observing the data that is going to come in. Which approach is better? And when you will use these approaches, which are called as schema-on-write, schema-on-read, we will understand by observing, by discussing few scenarios. Right. Data engineering and analytics. It revolves around the data, designing data warehouses, databases, tables. And while doing this job of designing data warehouses or databases, the critical decision is when should we define our data structure? Yes, if you know about your data, if you already know the structure and if you're sure that there won't be any changes in future, for example, employee database, for such kind of data, definitely first you will define the table. For transactions database, you will define the table. For CRMs, you will define the table first. But there are certain kind of data where you cannot commit on the exact structure of the table or schema of the table, like sensor data, social media data. First thing is you are not confident on the schema. There might be schema changes. In some scenarios, even you are not aware of your schema. Only after data arrives, you know what attributes are there in the data. In such scenarios, it is better to define the schema on read in the sense when you try to read data or to when you try to run the SQL queries, then only schema is applied on the data. Otherwise, data will be saved in CSV or Parquet formats. Let us discuss more about this. Schema on write, schema on read. Schema on write means you will structure the first. Usually in structured databases like MySQL, Postgres, Oracle, Microsoft SQL, in these kind of structured databases and in the data warehouses also, you will first define tables. You will give like column names and the attributes. And then you will ingest data into the tables, which is schema on write. Just now we discussed. Schema on read is first you will bring in data to the storage. Storage like object stores, data lakes. You will first bring your CSV files or JSON files or Parquet files, which has at least some structure, semi-structured. You will put in storage first and then define structure later. That is schema on read. And here schema is strictly imposed. If there is any schema mismatches, for example, employee database, you are defining it first, employee table. And later on, when you try to insert records into the employee table, it should match the exact columns. If there is an additional column or if there is mismatch in the data type, schema on write method will not accept. So schema on write is best for when you have sensitive data, it's transactional data, crucial data, when you want to maintain consistency, go for schema on write. Schema on read. Like you cannot tell that there won't be any changes in the schema in future. For example, IoT data, social media data, these kind of data is not in our control. In future, some additional attributes might come in or some mismatches in data types or column names might happen. For this, schema on read is better. Data first will be saved in its raw format without any strict schema enforcement. So, first of all, it will allow the data. It will not reject the data by applying schema on it. And then if the table is able to accept that raw data, it will accept. For example, if there is mismatch in data types, or like if additional columns are there, the table can accommodate. We have data warehouse platforms like Databricks, Snowflake, and lot of data warehouses supports this feature, schema on read. That is change in data types, additional columns. They were able to accommodate them. In some scenarios, if there are too many changes in the schema, then you can clean and write accordingly. Schema on read. Okay, for transactional data, schema on write is better. When you are saving data for analytics, schema on read is better. Let us take an example to understand this in more detail. Let us take a patient monitoring system. In this patient monitoring system, the hospital has different variety of data. Data coming from wearable devices like heart rate, activity levels, sleep patterns. This data is like event data. It comes in JSON format, semi-structured format. And also we cannot be very confident about the structure of this data. Like new version of variables comes into the market, they might come with new attributes. Then every time we cannot change our tables, alter our tables. For this, schema on read is better. Electronic health records, these are also same. Laboratory test results, clinical notes, observations, medical imaging metadata, patient reported symptoms and feedbacks. These are the data. Now, depending upon what purpose we are saving the data, and also the nature of the data. For example, wearable devices. Schema changes we can expect. Electronic health records. Who is using that electronic health records? Accordingly, you can plan the schema write and schema read. Laboratory test results. Let's see. See, incoming data is like this. Wearable data. It is like this. EHR systems. This also have varying structures based on medical events. These will be like this: patient ID, blood pressure, like health records. So all patients won't be having the same health record. They will be varying. Laboratory results. These has some structure. We get this data in structured CSV files. Now we have different variety of data. See, wearable devices, they are like in JSON format, semi-structured. In future, there might be change in the list of attributes. EHR systems are also same. Not only in future, in present also we cannot trust on the nature of this data. Attributes might change time to time. Whereas laboratory results, this data is more structured. Schema on write implementation. When to apply this? In schema on write, we will design a normalized relational database like this: patient vitals, lab results. Now, from these scenarios, from patient data or wearable devices data, EHR systems, laboratory results, we can extract patient data, patient's metadata, and this has to be consistent. We cannot accept duplicate records in patient, or like miscellaneous values in patient vitals. For such kind of data where you want to impose strict schema, you want consistency, you cannot accept duplicates, there you can go for this approach. You will define tables in advance. Whenever a laboratory report comes in the form of CSV file, you will load into lab results. table. And laboratory reports should strictly have all the columns, and it should also match all the column data types. We don't want any duplications here. In the same way, when patients got registered, that data should be entered into the table that is already defined. Now, the details of the patients which you are going to enter should exactly match the number of attributes that are there in table already, and also the data types. Now, here we want strict consistency. We cannot tolerate duplicates. There, we will define tables first, Schema-on-Write implementation. Okay, then we will come back to this ETL approach. Schema-on-Read implementation. When is this suitable? Like variable data, EHR data, lab data also you can put as a CSV file, clinical notes. In earlier case, the patient data, the lab results is used by application, healthcare monitoring system. And application has to show this. It reads the database like how many patients got registered, and who are the doctors assigned to these patients, and what are their lab vitals. We are managing in a strict imposed schema databases, that is Schema-on-Write. And later we are managing this data in some storage for analytics purpose. So I'm just dumping the data in a hierarchical folders: raw data, variable data, EHR data, lab data, and also data like patient records, laboratory data as a CSV files I am saving here for analytics purpose. And some data like variable data, EHR data, directly we are storing as a file first. We are not creating table here. That day data or that record, we will log into a JSON values, and we will save like day-wise JSON files or hour-wise JSON files. And now these JSON files will be imported to tables. We will come back to this ETL flow later. Then you will create a table. Create a table in using special tools like Spark, Presto, AWS Athena, or in platforms like Databricks. You can use SQL also to define the delta tables. These tables will refer to the raw data which you put in the storage earlier. For example, variable data. I'll create a table. First, I'll store the data in its raw format. I'll not write into the table. Later, I'll create a table which will refer to these raw files. Still, I am not trying to write the data into the table. Table is referencing to this data. Unlike an earlier example, I am not directly writing data into the table. Data is on its own format. Later, we will create table which is referred to this path. And then I'll query the table. I'll create external table like this, or a table. Why we are saying external table? In most of the lake houses, architectures, we use this word, especially in AWS Athena, we say create external table. From platform to platform, this changes. How you going to define the table? So we will create the table. While creating the table, you will refer it to the some path. For example, variable data is an S3 bucket. I created the table, and at the end you see I am saying it is stored as JSON format. In the JSON format, it is available in S3 bucket. Right now this is empty table, but it is referred, pointed towards this location. Now I will query the table. from patient vitals raw, which is the table we created, and it is pointing towards this path. When I query, then it will try to bring in data into the table and show to you according to your query. Right? That means when only you run your SQL query, it can be read query, write query, or insert query, upsert query, anything. Only when you execute the query, this schema will be applied on the file in this path. Now I have one file, like today's file is there. After a couple of days, a new file will come. That we are saying that all the files in the variables folder can be read into this table, can be written into this table. We are pointing this table to all the files in this location, and daily files are coming into this location. Let us say after few days there is a schema change, new attributes has added. Then accordingly this table will accommodate the changes. It will accept that new column, or suddenly there is a different data type is coming. For example, activity level is string. And in few records, activity level is some int. Then accordingly, it will accommodate the value. It will adjust the data types on the schema on read. This schema on read has these additional advantages. But when coming to consistency, duplications might happen. It might not impose strict schema. Because of that, outliers, miscellaneous values, duplications might occur. So when you want your data for analytics, you can plan data on schema on read type. And also schema on read type of tables are available in analytical type of warehouses, usually in data warehouses like or ETL platforms like in AWS Glue or Databricks, Snowflake. And when you want strict structure for your data, go for Schema-on-Write, which is with relational databases and also data warehouses like MySQL, Postgres, Schema-on-Write. Right, you'll create table first. That you will do in all relational database services. Now coming to ETL, see when you have structured tables, you'll collect the data and transform it and load the data. Suppose if there is any schema changes, you have to transform and you have to match the schema as it is guaranteed. If there are like any miscellaneous values, wrong unit types, like wrong data types, additional attributes, everything, then data needs transformation. After transforming, the transformation has to make data to match with the schema defined. Otherwise, it will reject. Here, ETL is bit different. Raw data collected in all sources without any transformation. And without any transformation, you can load into data lake with minimal processing. And when you try to apply the schema at query time, then analysis is needed. Like after bringing data into table, you will start, let's say, obviously, suddenly, JSON data is coming every day. In today's data, you have SPO2 values. Suddenly on third day data, we might be sensor is not working. That attribute is not coming at all. Missing. Then automatically schema on read will adjust it and writes null values. Or one more attribute is coming. It will accordingly add the table. Add the attribute to the table. But previous values, it makes previous values null. Later on, such kind of tables need transformation, of course. Later on, you will transform it. After imposing the structure, if you find any null values, duplications, other inconsistencies, then you will transform. Where in schema on read. But on schema on write, even before writing to the table, you have to transform the data. That is the difference. And when to choose what? Let us see decision framework. You will choose schema on write when quality is critical. Billing in transactions, regulatory reportings, where you don't have to stand to take the risk of inconsistencies or duplications, then schema on write, strict schema should be imposed. When query performance matters the most, you want quick queries. You're building real-time dashboards based on that data. Then always go for first creating tables and writing data into the table. And when you have mature data sources from the standards like HL7, FHIR, they won't change. Like very in the rare cases, data will change. Then also you can confidently define table first. When you have compliance and audit requirements, when concurrent write happens, multiple systems update patient records, then the table should follow strong ACID transactions. Then also first define the table and then write data into it. Schema on read. When you want to ingest data, data ingestion is the priority, not validating the data structure. Data ingestion is the priority, like search engine request, IoT data, clickstream analytics, log data, monitoring data. So these kind of data ingestion is the first priority. There might be duplications. There might be inconsistencies, missing values, new attributes, but ingestion is the priority. We cannot lose that data, even though it is messy. Then go for schema on read. Schema is unknown, like social media data, medical census data. You don't know. Even though you know the schema, it might be evolving. Then go for schema on read. Exploratory analytics, data science, especially schema on read is suitable for analytics. Then go for schema on read. Like for data science, you want to manage the data set for EDA purpose. Then you can create tables on schema on read. Diverse data sources, when you are merging data from different sources. Then also go for schema on read, because you cannot be very strict on the data that is coming in. You have sales data and you want to make some kind of analysis how sales is being affected by holidays, and you have holidays list, holidays data set in that year. You want to merge both of them. If you impose very strict schema, uh, it's not like it might not throw good results. So it's better to be flexible in such scenarios. Then go for data sources which provide schema on read. Storage costs and compute trade-offs. When you have large volumes of raw data, go for this, because here data is stored in object stores like S3 bucket in AWS, in open source in HDFS, in Azure we have Blob. That is the storage, and that raw files will be imported into tables when queried. Like we call it as a meta store concept. So comparatively, the data lakes, data lake houses, which provide schema on read, are more in terms of cost. They are cheaper when compared with data warehouses, which provide schema on write. In schema on write, directly the table's data is stored in the underlying storage. But on schema on read, first you are saving the raw data. And that storage which supports to store raw data is much cheaper than the storage of databases and data warehouses. So here, storage cost is less for the storage solutions which offer schema on read. And in real-time scenarios, we will use both. When you want strong ACID transactions, you will use schema on write. And storage solutions which provide this schema on write are nothing but our structured databases. All databases, relational databases, MySQL, Postgres, SQL Server, and so on, all are schema on write. The kind of like you can put them in that category. On the other side, data warehouses, data lake houses, data lakes, they provide schema on read. They are more on analytics side. And we will use both when we want to analyze the data. You want to merge data with different variety, and you have data like logs. Then we'll go for hybrid approach. Both of them, databases or data warehouses, and also data lakes where you store raw data. Yes, that is about schema on read and schema on write case.